Hi friends, in this session we will study about the number system. Math is a game of numbers. In mathematics we have to play with numbers. If we have to play a game, then we should know the rules and regulations of that game. The same way, one must know the numbers and their behavior with each other. In other words, we should know the classification of numbers, their types, their properties, and of course their operations. If one is aware about all these aspects, may be the master in mathematics. So let us start with the classification of numbers. So let us see the classification of numbers. We have classified the numbers in two parts. One is real and the other one is imaginary. First I explain you the imaginary part. Imaginary, if you have to find the square root of 36, what would the square root of 36? How will we get it? So we could get it by 6 into 6 is 36, and by minus 6 into minus 6 is also 36. You get it? 6 is the root of 36. Here you get minus 6. So the both way you could get it is either 6, because the 6 and 6 is minus 6, so we can get the positive value also here. So it is called the 6 is the root of 36. But if we have to find out the root of minus 36, so minus 36 comes with minus 6 and 6, the product of minus 6 and 6, or that is, we cannot find out the square root of minus 36, but it is not in the definition. In that definition, the signs would, both the signs should be same. If the one is negative, other should be negative, one is positive, should be positive. There is one is negative and other is positive, it is unable to find out, it is not defined, we cannot define it. So you see, we can represent it in this way. We can write 36 into minus 1. So let us see what happens now. We could write in this way, 36 into root minus 1. So we know the square root of 36 is 6 and the square root of minus 1 is root minus 1. We can write in this way. But this root minus 1 we could represent it by a small italic iota. It is called the iota. So we can write in this way 6i. So this is the imaginary number. So these numbers are imaginary where there is a negative sign in any root of any number. Under the square root there is any negative number, so it is called the imaginary number of the number. The first part, which is the real number, first I explained the imaginary, so we can distinguish these, the real and the imaginary. Every number we have studied from nursery to up to 10th about the real numbers. Okay, so real numbers like 1, 2, 1 by 2, 0, minus 3 by 2, negative is also square root of 2, square root of 3, square root of any number, the fourth root, the fifth root, these are all real numbers. Square root, fourth root, the even roots of all positive numbers, and cube root of any numbers, positive, either positive or negative. So these are all real numbers. So you see we have classified the real numbers in two parts, the rational and irrational. First I would like to explain you the numbers which we can express in the form of p over q, and q is not equal to 0, is called rational numbers, just like 1 over 2, 3 over 2, 1 over 4. So these are all rational numbers. So here you see what are irrational numbers, the numbers which do not terminate after decimal and neither a number or a block of number repeats, or it cannot be represented in the form of p over q. So the numbers, these sort of numbers like root 2, square root 3. Square root 4 is not an irrational number, it is a rational number, okay, because the square root of 4 is equal to 2, so it is not an irrational number. So this is called the irrational number. Pi is also irrational number because you can say that the pi is equal to 22 by 7. So how it is irrational number? It should be a rational number because it is in the form of p over q. But 22 by 7 is not the exact value of pi. It is correct up to 2 decimal places only. So pi is an irrational number. Pi is basically the ratio of circumference and diameter of a circle. So it is always be a constant number we get over there. So which is not 22 by 7, which is approximate. It is the approximate value of pi. So the 22 over 7 is rational, but pi is an irrational number. Now we see the rational number we have again classified in two ways: terminating, non-terminating. In the terminating way, you see the numbers which terminate after some places of decimal are called the terminating rational number. So terminate 1 by 2, 1 over 2, if you write here 1 over 2 is equal to 0.5. After 1 place of the decimal it terminates. After 2 place, after 3 place, 4 place, the number which terminate is called the terminating rational number. Non-terminating rational numbers are the numbers which do not terminate after decimal, and the number or block of numbers after decimal repeats infinitely. So look at this: 10 over 3 is equal to 3.3333 and so on. So we get this thing. So it will not terminate infinitely. So we can write this number in this way: 3.3 bar. It means this particular number is repeating again and again up to infinite times. So I explain you one more thing here. You have to find the value 1 over 7. So what we will do? This is our 7, this is our 1. I write 1 here. You put first point here, so we get 0. 7 1 times 7. Now remainder is 3. We get another 0 because the point is we have applied here. So 7 4 times 28 we are getting here. Now the remainder is 2. Now again 0. 2 times it is 40 now. Now 6 remains, we got 0. 7 8 times it is 56. It is 4 remainder now. It is 5 times 35. Remainder 5. It is 7 times 49. Remainder 1. So we again get 10 here. So you see here the same thing will be repeat again and again because we have got here 10. The 10 it will go through 1 times, then remainder would be 3, it will go through 4 times. So that this block of numbers 1 4 2 8 5 7 repeat again and again. So we can write in this way. So this is a rational number which is non-terminating, or we could say the non-terminating rational number. The block of numbers after decimal is repeating. Okay, so this is the non-terminating rational number. Now if you have number and you have to find out without dividing it by the long division method, you just want to know whether it is terminating or non-terminating rational numbers. So I will tell you about this. If in the denominator, just like 2 over 5, so 2 over 5, you see here in denominator there is 5, so it is a terminating number. If in the denominator 2 to the power m or 5 to the power n, or both 2 to the power n and 5 to the power n, or both, then it is terminating. Besides this, if there are some other prime number like 3, 5, 7, so it is not a terminating rational number, then it would be a non-terminating rational number, just like 1 over 15. So you see, if you factorize 15, if we get the factor of 15, it is 3 into 5. So here is 5, but there is another number which is not 2. It should be in the product of 2 or 5 or with any power. So here you see it is 3, so it is not a terminating rational number. It is non-terminating rational number. So in this way you could easily find out whether the number is terminating or not. Just look at in the denominator, see whether there is factors other than 2 or 5 with 2 or 5 or both, then it is non-terminating rational number. So this is a way to recognize how to recognize the terminating non-terminating rational numbers. Now we start with the natural number. The natural number, you are all aware about the natural numbers. The definition of the natural number is the numbers which we use for counting are called natural numbers. So the counting we always starts with 1, the 1 positive. So we get here 1, 2, 3, 4, 5 and so on up to infinite. We get these are all the natural numbers. If now we see what is whole numbers basically. So if we include the 0 in the set of natural number, the set is called the whole numbers set. So here you see 0, 1, 2, 3, 4, 5 and so on up to infinite. So these are whole numbers. Now integers. If we include the negatives of natural numbers in the set of whole numbers, the set is called integer set. So look at this. Dash because -3, -2, -1, 0, 1, 2, 3 and so on. So these are all integers. The natural number is not negative, but we take the negative of natural numbers and include these in the set of whole numbers. So we get integers, not decimal numbers. So here you see we have seen the natural number, we have seen the whole number, we have seen integers. The smallest natural number is 1. The smallest whole number is 0, but the smallest integer is not defined. Now above these we get terminating, non-terminating rational numbers, and our tree completes upwards. Now we see some other roots of these number systems. There are 4 major roots here: even, odd, prime and composite. These are our stem, the natural number, whole number, integer. These are our stem of this tree. And here you see on the other side you see these are our branches, the 2 branches we have got here. Here also branches. So this is our whole tree we get in this way. So here you see now the roots we see even, odd, prime and composite. The even number, the numbers which are divisible by 2 are called the even numbers. So look at this here. So it is 2, 4, 6 and so on. So 2, 4, 6, these are all even numbers which are divisible by 2. The smallest even number is 2. Odd numbers which are not divisible by 2, the natural numbers which are not divisible by 2 is called an odd number. So it is 1, 3, 5, 7, 9, 11 and so on. These are all odd numbers. Now the prime numbers which are not divisible by any other numbers except 1 in itself. So it is 2, 3, 5, 7, 11 and so on. So these are all prime numbers. So look at this here. The smallest prime number is 2 and 2 is the only even prime numbers. The other numbers are odd prime. And the odd numbers, you see the smallest odd number is 1, 1, 3, 5, 7, 9, 11. And the smallest even number we have already seen here, it is 2. Now the composite number, the numbers which are the product of at least two prime numbers are called the composite numbers. So let us see. The numbers which are not prime is also called composite numbers. So the 4, 6, 8, 9, 10, 12 and so on. You see the 4 is the product of 2 into 2, the two prime numbers 2, 2. And the 6 is the product 2 into 3. It is the product of 2 power 3. If we write, we get 8. And 3 power 2 is 9. 2 into 5 is 10. 2 into 2 into 3 is 2 power 2 into 3 is 12. So in this way, the product of at least two prime numbers is called composite numbers. So we have seen that the number tree in this way. Now study about the co-prime number. If there is no common factors between two or more numbers, the numbers are called co-prime. Every prime number is co-prime of the other prime numbers because there is no common factors among them. Look at here. You see the prime number I have explained you here. The prime number 1, 3, 5, 7, 11. You see 2 and 3 are co-prime because there is no common factor except 1. Okay. There is 3 and 5, it is also co-prime for each other. 5 and 7, this is also co-prime for 7 and 11, the 5 or 11, 3 and 11, these are all co-prime of each other. But here in the composite number, you see the 4 and 6 are not co-prime because 2 is a common factor in the 4 and 6 both. 4, 6 and 4, 8 is also not a co-prime because there is 2 common factors. 6, 8, there is a 4 common factor in 4 and 8. In 6 and 8, you see there is also 2 common factors there, and 6 and 9 there is also 3 common factors there. But 8 and 9, if you see 8 and 9 here, 8 and 9, so both are co-prime of each other because there is no common factor between 8 and 9. There is also in 9 and 10, it is also co-prime because there is no common factor between them except 1. But here you see that 10 and 12, there is a common factor 2. By 2 both the numbers could be divided. So in this way we see how we get the co-prime numbers. Every prime number is already co-prime of other prime number, but in the composite they are also co-prime. There is no common factors between or among them. So here you see the smallest composite number we have seen here 4. The smallest prime number is 2, which is only even prime number. The smallest odd number is 1. The smallest even number is 2. We have also aware about what are the co-prime numbers. So we have seen here, we have seen whole the tree of numbers here. Thank you.